on days where there was this amount of precipitation in New York City, you'd realize that's a really, really hard problem to answer. And you're going to spend a ton of time doing data prep. And instead, one thing we did with Planario is we automatically consume all the NOAA data. So all incidents are then joined with the weather data so that that's available to take this step out of the process and make it easier. And at the same time, we've spent a little time building some interfaces to make queries easier. But the core behind the project is really, really simple. I don't care about any of these visuals. I care about the fact that I offer up a documented API, which lets people call, that gets back to that question of my new generation of policy data scientist folks who can spin up our connects to the API. And when Mayor whomever says, show me this distribution, I need it in 30 minutes for a press conference with a basic idea of the descriptives, that's possible. And that's a different way of doing business. And again, that goes back to that idea of data-driven not just being talk. So for those of you that are spatial experts in the room, we have more and more policy that is based on maps. But maps are kind of problematic when you get into this, and our sort of experience with maps have changed. So I gave a talk to Strata, the data science conference, a few weeks ago, and I asked the question, how many people know a cartographer? And let's just say there were about 200-300 people in the room, and there was one hand. Does anyone know a cartographer? Okay, 2, better ratio. Okay, so anyhow, so when we think about maps, let's talk about how do we measure poverty. Now, here we have the polygons for zip code, right? And you see the geometries there, and then you see we have the aggregations, and this is how it looks. Okay, county. Oh no, what do? I'm a policymaker. Oh no, well then maybe we'll try something new. How about oh crap. Oh, nope, no idea what to do. Census tract, oh, wow. We are just a mess. And so based on the geometries and the polygons that I use, I am amok. So you have this wonderful thing called the modifiable aerial unit problem, which many of you are probably familiar with, that talks about the various arbitrary units of analysis that you can use that can muddy the problem at hand. So I came up with this idea of how can we build maps based on the problem at hand. And this, I call them blobs. I'm sorry, I'm not good at naming. I didn't name OpenTable. I wasn't good at that either. My wife named the kids. So the idea is, how do we get maps that make sense based on the problem that we have, and how do we hook it into something like Planario so we can answer the questions and we don't have the geometry confusions like I had before. The idea behind blobs is this, you have maximally similar within and maximally different from your neighbors. And so ASU, Arizona State, has an algorithm called MaxP. And what MaxP does is it creates units essentially based on a floor attribute. And you start to create your own maps here. So here's an example of, let's sort of flip ahead to a MaxP generated a la blobs of violence in Chicago. And then you look at the districts as used currently. Now, what's interesting is right there. So you're identifying a behavior there that is lost in the resolution of the geometries used by the police. And it's not just the fact of identifying small behavior, it's creating these units that are maximally different. So blobs brings this idea of meaningful groupings so that we can understand, based on the attributes that we care about, the nuances of the environment. So we created this thing that we call the blobs generator. So, and there's lots of code to go along with this. If you actually go to Chicago Harris's GitHub site, we have all the code up there. We have a variety of tutorials. The basic idea is blobs hooks into Planario, because I'm very focused on keeping this open. You then run MaxP, which was formerly kind of tricky to use, and we've made it easy. And then we take the output of these homogeneous, either univariate or multivariate areas, and then we run k-means against it, because we want to cluster it together. So it wasn't sufficient to me. So MaxP produces these maximally different units, but say you have a unit on the southeast side that's generated, and then one in the northwest corner that are actually really similar. That's material, because as you think of tailoring treatment for government, you want that k-means cluster. And that's actually a lot of fun, because you find areas that hang together in counterintuitive ways. And this, we think, is a great way to start using for both policy, government, but also on the science side. So where does this all tie together? So a project that's funded by the Arnold Foundation is aptly named Weather and Crime. Remember, I like weather data. So the idea is that there's plenty of historic data, academic data that talks about the relationship between weather and crime and temperature and all that. But it isn't high resolution, it's not granular. Now, going back to the work I did at the police department where I focused on prediction, my job was to predict spatially and temporally where violence would occur. It's a problem we have in Chicago. Now, we noticed that weather was very impactful, but not in obvious ways. It wasn't just about it being hot outside. There were interesting patterns where when the temperature would rapidly rise from a starting point under 50 degrees Fahrenheit, bad things would happen. Rain, under certain circumstances, wouldn't have as much impact. So it became very interesting. So we're wrapping up year one of the Weather and Crime Project, and this is notable because the worlds it brings together. We know the policy world, and we know the public safety, and we know deployment, and we know those pieces. But in this case, we build machine learning models, primarily neural networks that run on Argonne's supercomputer. And Argonne's supercomputer builds the models. We then leverage part of the Harris computing structure, and then it pipes up into Heroku. And we have an app here which will be released shortly, and I'm giving you a preview. No tweets again. And you're looking at hour-by-hour predictions at the track level for violent crime. That is something that hasn't been done before, because it brings together sort of the expertise in policy, computing that is just not typically available, and then merging the worlds of, like on my advisory group, you have Jeff Grogger, who's just this amazing professor at Harris. He is just a guru of classical statistics, me and whatever I am, and someone like Charlie Catlett from Argonne National Lab. That's a combo that you just haven't really seen before, and by bringing this together, you're able to move to that high resolution tailored treatment. So we look forward to, when you think about today and you think about the discussions you're having and you'll have over the next few days, these are worlds that need to intersect. We need to get out of our comfort zone. We probably need to be a little less rigid. We need to accept the sort of dirtiness of data. We need to embrace the creativeness of these techniques, bring together these resources of supercomputing, and then focus on the pipeline. Who are the people that we want to produce as the next crop of scientists? And some will be in academia, some will be in government, some will alternate between those, but there's a real appetite for smarter, more effective policy that deals with this near real-time situational awareness-enabled world that can be very impactful for the future years. So sorry I went a couple minutes over, but thank you.
Can you pull this up? So that was fantastic. I think that gave you a terrific overview of exactly why we had this workshop, right? That there is this whole new world of data out there. What I thought, Paul and I thought would be a very good kind of discussant for this is our world for many years has been dominated by the data produced for us by the federal statistical agencies. Now clearly, in a recent study, the American economic journals, 70% of the data are now coming from the private sector from the types of data that we've been talking about today. The federal statistical system is paying attention to how things are changing. And Ron has been one of the leaders, I think, in the federal statistical system to think through what the implications are for the way in which data are collected by statistical agencies and the way in which statistical agencies can leverage the information that is being produced. So we asked Ron to comment, and he has 5 to 7 minutes.
So how do I make this full screen?
We're full service here.
There we go. Oh, perfect. All right. So knowing I didn't have very much time, I went ahead and everything I want to say about Brett's talk is right here. And that's 96-point font. I can't go over 100. Sorry.
I'm so hurt.
That's for like something really, truly, utterly amazing, like aliens landing or something like that.
That's next.
So okay, good. So but I would be a bad discussant if I didn't say but something. And this isn't really about Brett's stuff. It's more generally about thinking about this day, and about all the new tools and stuff that we've been talking about, and all the new data sets. And so so I just tools are only as useful as the data are good. So in Brett's case, and we had a talk this morning about crime as well. So in this case, we got reported crimes only. And so if we're talking about the effectiveness of public policy, the public wants all crime, the total crime rate to go down, not just what's getting reported. So somehow, how does the public policy professional get access to the thing that's actually driving the public's happiness or anger? Then things like mashups for small geographies can be very noisy when the different data sets have different qualities and stuff like that. So these are things that we need to be careful of. But I think for a lot of what folks here are interested in, lots of policy domains require access to restricted use data, stuff that doesn't get to go live on these cool tools. And so how do we marry the tools with the data? I think that's the thing we really need to be thinking about. But then, I just threw this point in to be kind of a little pithy, but it's, I think, somewhat true. Are we just the same drunk looking for our keys under just some new lights, right? We used to just have the light that was a survey, and so we were the drunk looking for our keys under that light. Now we have some new lights, but the answer still is in the corner of the parking lot with the light that we haven't found yet. So we need to be careful for those sorts of things. But so the policy issues on getting to the marrying the tools with the data, I think, are still unsettled. And so, and that's going to impact how much we can improve public policy by using these new data. And so, one thing I asked, do citizens really want a heavy police presence in their neighborhood because an algorithm is predicting a crime? I mean, I think that's an interesting question, and maybe that conversation needs to be had. Maybe do some experiments, and if we really do reduce the crime rate because of that, but who knows? I mean, I think you might kind of, some people might be creeped out by that. So then, if we're thinking about how to kind of move forward and to make sure that the data we need get brought to bear on the questions that we need to answer. So, I'm not going to pretend I have all the answers for this, but we do spend a little bit of time at a place like the Census Bureau thinking about these things. So the first thing is to free the data from the silos. All right, and that's kind of an easy thing to say, but it's a harder thing to do. So at the federal level, the Murray-Ryan data clearinghouse is I think an attempt to start thinking about how you would put the data where it needs to be so that researchers and folks could get access to it and answer the questions that they want to test. So how do we try to do that? You need a trusted hub or hubs for provisioning the data with the appropriate governance. And so this might not just be one thing, it might be many things, with ways for those things to talk to each other. But I think we need to, that's probably the path that we need to go down. And then facilitate linking to high quality frames. So a lot of the data that we're talking about here they're either unstructured or their coverage properties are poor, and the ability to link to frames where we know the scientific properties, I think is really important to be able to try to put some bounds around what we think the quality of the answers we're going to get from these data. And then finally, facilitate linking of policy interventions to other data sets at the micro level to the extent that you can. We heard a couple folks say, well, you can link that to tract level data to get some characteristics. Well, there's a lot of heterogeneity inside of a tract. And so, that's the, I think that's what your blob thing's trying to get at. You're just going to have to the greatest extent that you can, actually do the linking at the micro level in a secure way and then extract your answers out. So I think I'm out of time, and so I'll end there. So thanks.
Thank you. So we have time before our hard stop at 5 o'clock for 1 or 2 questions. Yes, and please name and affiliation.
So I think, so that's, you're dead on, right? The challenge, well, the reality is they're both important, but sometimes they stand in the way of each other. Now, when I started in the prediction world, I used to battle with people that were saying, well, you're not caring about causality. And my point was, like going back to sort of not the open table days, but the police days, what mattered was I have a proposed treatment in the target area to prevent someone from getting killed. And if the day after I was able to turn back to causality, that would be great, but hopefully dude wouldn't be dead. And that in 2011 was considered a little flawed. And we saw this both in Chicago and New York, where a lack of attention to causality sort of impeded prediction. Now, what I'm afraid is happening as we get into, we're 15 into 16, is we're so focused on prediction that we might potentially ignore causality. So I think we as practitioners and researchers need to embrace both, understand the differences between both, and be respectful, but also realize that if you're able to do a smart prediction and make meaningful change tomorrow, we should do that. But let's not forget the causality.
On that note, I will be killed by Ken Couch if we don't stop exactly at 5.
We can prevent that by predicting it.
So I invite you to come and talk to Brett and Ron afterwards. I think Paul and I would both like to thank you very, very much for attending. Great conversations and just great engagement. So thank you very much, Paul. Thanks. Ite Masa Est.